Hi everyone, I am Madhumita from Open Forest 4D. In this video, we will work on how to navigate through CloudCompare and complete Activity 3. CloudCompare is a free open source tool to view and measure 3D point clouds. In the activity, you'll use CloudCompare to derive two forest metrics, canopy height and crown width. We will cover four things in the video: loading a point cloud, moving around the 3D scene, switching the attribute used to color the points, taking direct measurements on individual trees, which is subdivided into measuring canopy height and crown width. So let's get started. Before we begin, note that the Activity 3 document contains the information for downloading Cloud Compare from the internet. Follow those steps and Cloud Compare will be installed on your laptop or PC. Once it is installed, click the Cloud Compare icon to open the software. You will see an empty workspace like this one. Activity 3 repository gives you two last files and you're expected to download them and store them in your local laptop. Once downloaded, go to File and select segmented trees.las from the store folder. Click on Open. Cloud Compare will ask about a global shift. Accept the suggested shift by selecting Apply All and Yes to All. This moves the cloud nearer to the origin for display only. Your measurements stay correct. The cloud now appears in the 3D view. On the left is the DB tree, which lists every entity currently loaded. Below is the properties panel, which shows the details of whatever you select. So click on segmented trees.last file and the properties appear below. Load the normalized cloud in the same way. Now that we know how to load the point clouds, it is important to understand how to navigate the 3D scene. Currently, we have two point clouds situated in the opposite ends of the worksheet. Use the right click and drag to get the point cloud to the center of the workspace. The scroll wheel zooms in and out. I'm currently trying to zoom in. This is how the point cloud looks. You can use left click and drag to rotate the scene. Top, front, and side views are the ones you'll mostly use. Top view is used for crown width. The front view is useful for checking height. Point size display makes the interpretation much easier. Use the plus and minus keys to make the points larger and smaller until the canopy reads clearly. A point cloud carries more information than just position. Each point stores extra attributes called scalar fields, and Cloud Compare colors the LiDAR point cloud using one active field at a time. Select the point cloud in the DB tree and then look into the Properties panel. Find the scalar field section. The active field is currently set to intensity. Switch the active field to tree ID. This field was generated ahead of time by a segmentation step. Each tree receives its own identifier, and the color ramp now shows individual crowns as distinct colors. This is what allows you to pick five separate trees with confidence rather than guessing where one crown ends and next begins. With tree ID as the active field, individual trees are now color coded. Pick five canopies and begin the crown measurements. This activity covers canopy height and crown width. Canopy height is measured in two ways in this activity, and comparing them is point of the exercise. Select the segmented trees point cloud. Zoom into one canopy using navigation tool. Make sure the entire canopy is visible. Once done, click on the points picking tool or simply click on the fourth icon that you see. A toolbar appears to the right. Select the second icon, which uses 2 points to compute the distance. Once selected, click on the ground point first and then click on the top of the canopy. The distance between 2 points is measured, and distance between 2 points in each direction is also given. Get the delta z value and record it in the table. Now that's done, switch to normalized point cloud. Normalization has already subtracted the terrain surface, so ground sits at 0 everywhere. Here, the z value of the treetop is the canopy height directly with no subtraction needed. So, click on the point picking tool and click on the first icon that you see, which selects one point and displays its information. Once that's selected, zoom into the canopy of your choice. Make sure you use the same five canopies. Zoom into the canopy to get a clearer view and click on the top of the canopy. You get the information of that point. Select the ZL value and record it in the table. Similarly, take five measurements and record it in the table. Once the canopy height measurements are complete, move on to the crown width. Use the same normalized point cloud and the same five canopies. Zoom into one canopy, but this time switch to the top down view using the navigation tools. With the normalized point cloud selected and the canopy in view, open the points picking tool and click on the second icon. Select one edge of the crown and then click on the opposite edge. The tool returns the distance. Record the delta xy value since that is the width of the horizontal plane. Next, estimate a perpendicular to the one you have just measured. Select one point in the perpendicular direction, which is the edge, and select the other end of the edge. You will get another distance and record the second delta xy value. Enter both values in the table provided and compute their average. The average is the crown width of that tree. Repeat this with all the five canopies, and for each canopy, take five separate measurements and record them in the table. That covers what you need in Activity 3. Load your clouds, set tree ID as the active scalar field, measure height on both the raw and normalized clouds, and measure two perpendicular crown diameters from the top of the view. Walk through the activity sheet from here and refer back to this video whenever a control is unclear. Thanks for watching.